In section 7.7, we're going to look at what are called complex numbers. So up to this point, we have looked at square roots with a negative on the inside, and we've been careful not to say that there is no answer. What we've been saying up to this point is that the solution is not a real number. And that is correct. It's not a real number. We're going to find out in this section that it's not a real number. It's a complex number. So what will happen is anytime we have a negative inside of, this only works for square roots, a negative or a -1 inside of a square root, it will come out as an I. The I stands for imaginary. So what's going to happen is whenever you have the negatives inside of a square root, it will come out as an I, giving you what's called an imaginary or a complex number. So if we look at this first example, the square root of -16. On this first one, what we would have is we've got the square root of, well, we already know how to take the square root of 16. The square root of 16 we already knew was 4. But now we're being told that negatives inside of a square root will come out as an I. So I'm actually going to get an I next to my 4, and that's my final answer, is that the square root of -16 is 4I. Let's try another one. Let's look at the square root of -49. Well, we do know that the square root of 49 just by itself is the number 7. But now we have a square root of a negative. Before we didn't know how to deal with it. Now we know that the negative underneath the square root will come out as an I. So our square root of -49 is a 7I. Let's see, let's look at one more. We've got on this next piece, we've got the square root, let's see, of -25. Well, we do know that the square root of 25 is 5. And we were just saying that the square root of a negative on the inside of a square root would come out as an I. And we have our normal just 4 plus on the outside. That won't change. So what this gives us is 4 plus 5I. And the question is, can we just leave it like that? And yes, you can. You cannot add the 4 and the 5I because they're not like terms. Just like if you had a 4 plus 5x, you couldn't add those because they weren't like terms either. You'd have to leave them as separate pieces. So that is what's called our final answer, and that's more of what we think of as a complex number, where you have a regular number that comes first. That's this little A part. It's just a regular real number. And then you have this imaginary part, let's call that BI, at the end. And so we've got a real part and imaginary part. That's what we really think of as a complex number, when you have a real part and an imaginary part. Now, do you have to have both a real part and an imaginary part? Absolutely not. A real number is a complex number. An imaginary number is a complex number. So, when we think of complex numbers, let's see, just to give you guys an idea. So when I think of complex numbers, they don't just have to be the real and imaginary together. They could just be a regular, just real number. Or they could just be an imaginary. Or it can be a combo. It can be both. It can be a real part and an imaginary together. Any one of those are all considered complex numbers. Okay, now we do like to put our complex numbers in what are called standard form, and that's what this a plus bi is. It's standard form. What's weird is we do like the imaginary number to be here at the end, like it's listed here. I know with x's we like seeing them at the beginning of our terms, but with i's we like seeing them in standard form, which means we like seeing them at the end. So a lot of your problems will say they want them in the form a plus bi, and the reason why they're saying that is they just want to make sure that they put your I at the end of the complex number instead of at the beginning.